To compute the duration of anything, we just need two building blocks or two rules. Okay, so rule number one, the duration of a zero coupon bond is very simply the time until maturity, all right? So this just comes directly from the definition. If you do the derivative of the bond price with respect to interest rates, as you see here, you immediately get that result, all right? So quick example. Let's consider a portfolio manager that has a 3-year strip. Okay, so recall that a strip is just like a zero coupon bond. So this is a bond that matures 3 years from now and pays no coupons until then, right? And let's say the market value is $10 million. Okay, and the question is, by how much will the portfolio value change if interest rates increase by some amount? Let's say 1 basis point. 1 basis point, okay? So what we do is the following. So again, a zero coupon bond, or a strip in this case, looks like this, no coupons in the meantime, and a maturity of 3 years where we will receive the full amount, okay? So the duration is the time until maturity, 3 minus 0, that's 3 years, right? And then the question was, how much would the bond price change for a given change in interest rates? So this is the definition of duration that we have here. So I can write this with the change in price on the left, as you see here. Okay, move everything else to the right-hand side. In reality, interest rates do not change by this infinitesimal amount, by this dr. In reality, they move by some discrete larger amount. Okay, so this becomes just an approximation. Instead of a strict equality, it becomes an approximation. So a discrete change in price is approximately equal to this expression where you have now here a discrete change in interest rates, as happens in reality. Okay, so for this problem, the duration was 3 years. The value of the portfolio or the bond is $10 million, and then we are assuming a positive change, so an increase of 1 basis point. Okay, which is this amount here with a positive sign again. All right. So the final result is that if interest rates increase by that, the bond value decreases by $3,000. All right. So just to stress this interpretation of duration, that it is a good approximation for small changes, but as the change in interest rates become larger and larger, the approximation becomes less good. Okay, so if we plot here the price against interest rate, or the new price against the new interest rate, what you find, let me open this figure. Not this one. Okay, so what you find is this. Okay, the price is a function of interest rate. The star here denotes the new interest rate after the change, and the price with the star denotes the new price. Okay, so before the change, we are here at this point, price for a given interest rate. So this point here in the curve, right? We know that interest rates, that prices change with interest rates in this type of non-linear but decreasing and convex shape. Okay, so this would be the true price if I actually computed the price by discounting cash flows in an exact way. What we are doing with the duration concept is doing an approximation, which is this linear approximation here, right? And this is the expression we had in the handouts, right? So the new price is approximately equal to this expression where the duration comes in, right? So for example, if the change in interest rates is large, as you see here in this figure, you get an error which becomes a bit bigger, right? Okay, let me just stop something here. Okay. All right, so back to the handouts. This was rule number 1. Rule number 2, the duration of a portfolio. So the duration of a bond portfolio is very simply the average of the durations of the bonds that we have in the portfolio. Okay, so DI is the duration of bond I, and then we do a weighted average. Okay, what are the weights? Well, are the natural weights, in the sense that they are the value of each bond over the total value of the portfolio. Right? So let's do this with an example. So it's again a portfolio manager that has 10 million invested in the same 3-year strip of the previous example, but now we also have an additional 20 million invested in another strip, a 7-year strip. Okay, and then the same type of question: by how much will the portfolio value if interest rates change by a given amount? Let's say 1 basis point. All right. So now let me open the file. Here. All right. So the duration of the portfolio is again the weighted average of the individual durations. There were two strips. The first strip had a duration of 3, and it had a value of $10 million. The total portfolio was 10 plus the 20 of the next one. So 20, the second bond, $20 million of market value, and the duration of 7. So the weighted average gives me a portfolio duration of this, 5.667, right? So what is the change in the portfolio value if interest rates change? The same type of expression as we saw in the previous example, right? The duration of the portfolio comes in at 5.667, the total value of the portfolio 30 million, and the same 1 basis point increase in interest rates, right? So if interest rates increase by this, the portfolio value decreases by $17,000, right? So these are just very simple examples. Obviously, I can always compute the value of a portfolio for a given interest rate exactly by doing the present value of future cash flow. And I really don't need the duration to do this type of exercises that you see here, right? So this is just to warm up for us to understand how the duration works, okay? But it's not something very useful that will be applied in the future. Okay, so just to understand the duration formula. Okay, but the point is, at this moment we have these two rules. The duration of a zero coupon bond is the time until maturity. The duration of a portfolio is the weighted average of the individual durations. And with these two rules we can compute the duration of anything under the sun. Okay, so we'll do the applications in the next video.